have seen how the Sobel and Canny edge detection algorithms are working. So in this example here, or in this video, we will try to dive into the Laplacian edge detection algorithm. And this is, for instance, the filter, how they use the filter. They use uh, uh, the second derivative of the Sobel algorithm is use first derivative. And in here, I would like to show you how did they get this filter here, or maybe this. So let me just go back to the beginning. So let me just see some info about what is the edge. So why we need edge detection indeed. So already explained in some other videos, but imagine I'm just assuming that you are starting from here. So it's used for object detection, segmentation, medical imaging, robotics, and etc. And Laplacian use second derivative, strong response for at sudden changes. If there's any sudden changes, it will be detected. And the edge detection, it will be detected in all directions at once. And they have a simple kernel 3 by 3, and we will see this. So imagine in the calculus we have, for instance, we have some formulas that we need to get the first derivative or the second derivative, and assume here that we have a signal or maybe image, and let's assume that this is the values here of this of this signal here, or maybe the image. We are using images. Now the first derivative here is for the differences. So what is this? It will be 10 minus 10, it will be 0. Then 10 minus 10, it will be 0. 50 minus 10, it will be 40. 200 minus 50, it will be 150, and etc. 50 minus 200, it will be minus 150, and this. That's it. So this is the first derivative. Let's see. Let's use in the Sobel algorithm. Now the second derivative, we will use the result of the first derivative and apply the second derivative, which will be the same. It will be, well, just 1 minute. It will be 0 minus 0, it will be 0. 40 minus 0, it will be 40. 100 minus 40, it will be 910. And this minus this, it will be minus 300, and etc. So you can see this is the second derivative here. Now we would like to see how they get the filter, the filter, and this is the in the x direction. This is the derivative in x direction, and this is in y direction. And if they combine this, they will get this one here, minus 4x yx. So if you just sum up all of these, you will get this one here. Now let's see. This is the x. I mean, this is the center pixel, which will be 4 minus 4. You can see minus 4, and this is, so for instance, this is x xy, and this is x. Let's see. Wait a minute. This is the right. This is the right x1, x plus 1. This is the x direction, and this is the y direction. Let's see. And this one here is x plus 1 y, and here x minus 1 y, and here x minus 1 x and y minus 1. So we have more minus 1, and here uh, x, then y plus 1. And you can see this is, for example, 1 1 1 1 and minus 4. So this is the center pixel is minus 4. This one and the other are zeros. And sometimes they have been using 8 connected pixels. For instance, this one here. And this is just to show you how the Laplacian filter is getting. So after this, you can apply the kernel, let's say the convolution. For instance, assume that we have this image here, and I would like to apply it on this region here, just for example, we will do it for every pixel here, every pixel, but for now, I will just select this region here, center pixel, center, let's see this one here. Now I will get I will multiply the filter that we have already. Let's see, it's already getting, but I just showed you how we got this filter here. Now we will apply, will configure the filter on this image, and we will see 1 minus 1 times 50, 1 times 50, 1 times 50, 1 times 50, minus this one, and the other one are zeros. So we have now minus 600 strong edges, which is strong edges. If you go back to the figure here, yeah, we have seen if it's greater than 0, it will be dark. It will be brightness edges. If it's minus, it will be dark edges. And let's see now. And of course, if it's 0, it will be no edges here. And this is the Python code. I can also show you the stuff, but let me just show you here. So you can see this is the same example we have what we already used, and this is the filter we have. I mean, we see how did they get the filter indeed. Now you can see the Laplacian, applying the Laplacian filter because it's 2D images. Now we sometimes they get the minus 600, as we have seen in this example. They have minus 600, but we need to show something, right? So we have to taking the absolute value, then normalize the image and convert it to unsigned integer 8. Now you can see now if we show, this is the original image, this is the Laplacian, and this is the Laplacian normalized image. So you can see we have detected the edges here. I think that's it for today, and thanks for watching. If you have any question, just drop it down in the comment below. I will definitely answer it.